Assalamualaikum and hi everyone. This is the last chapter for this subject. Okay, chapter 5, Fourier series. Okay, Fourier series is a way to represent a periodic function as the sum of sine and cosine function. What is periodic function? Okay, periodic function is a function that repeats its pattern at some period. We have this graph of periodic function. So at some period, this period, the graph is repeated. Okay, look at it. This is the period and the graph is repeated like this one. It's same for this one. Okay, after some period, the graph is repeated. For periodic function, we have this notation, fx plus 2l. So this 2l is the period. Okay, selang masa dia. Okay, the pattern is repeated after 2l. Okay, if we have this function, so the period is 2l because the graph is from negative l to l. We start from negative l to 0, 0 to l. So we have 2l. And then the pattern is repeated after 2l. Okay, after 2l, we have this graph. So this is an example of periodic function. For this example, we have fx plus 4 pi. For periodic function, we have fx plus 2l. So for this example, 2l equal to 4 pi. So l equal to 2 pi. Okay, sometimes the question asks you the values for l. This is the graph for this function. You draw from negative 2 pi to 2 pi, negative 2 pi to 2 pi, and the function is x. So this is the graph of x. Fx equal to x. Okay, look at here, L equal to 2 pi. The length of each side is 2 pi. So from negative pi to 0 is 2 pi, and this one is 2 pi also. So overall is 4 pi. And the same pattern of this graph is repeated after 4 pi. From here to here is 4 pi. Same for this side also, we have from negative 2 pi to 6, 2 pi is 4 pi. Okay, these are subtopics in Fourier series. So you should be able to first determine the type of functions. Okay, for single function and also for periodic function and graph. Okay, we have three types of functions, even function, odd function, and last one is neither function. And then second, you should be able to plot periodic function graph. And last one, you should be able to calculate or find Fourier series. In this lesson, you will learn how to determine the type of function. Okay, for single function like this, we have function of fx. To determine the type of function, you must substitute x, okay, this x with negative x. Okay, after you simplify, if f negative x equal to fx from the question, so the function is even. If f negative x equal to negative fx, then the function is odd. But if f negative x is not equal to fx and is not equal to negative fx also, then the function is neither. Okay, for periodic function, you have to plot the graph first. Okay, from the graph, you will determine the type of function. For even function, the graph is symmetry at y-axis. Okay, symmetry at y-axis. Okay, we have symmetry graph. For odd function or for odd graph, the graph is symmetry at the origin. So this is the graph and the graph is symmetry at the origin. For neither function, the graph is not symmetry about y-axis nor the origin. Let's go in detail for each function. For even function, f negative x equal to fx. Okay, look at this example. Fx equal to x square. You substitute x here with negative x. So we have f negative x. Okay, this x substitute with negative x equal to this x substitute with negative x. So negative x square. Negative x multiply with negative x, you will get x square. So x square is fx. So equal to fx. F negative x equal to fx. Then this function is even function. Okay, the graph for even function is symmetry about the y-axis. It look like mirror image. If you put the mirror here on y-axis, you will get the reflection of this graph like this. Okay. But the left side is exactly the same as the right side. For odd function, when you substitute f negative x, you will get negative fx. Okay, look at this example. We have fx equal to x power of 3. Then substitute negative x. X here you substitute with negative x. So we have f negative x equal to x here also you replace with negative x. So negative x power of 3. Then multiply negative x, negative x, negative x, negative cancel. You will get negative x power of 3. Then we refer to fx. This is not equal fx. Then you refer with negative fx. Okay, we have fx equal to x power of 3. So negative fx is negative x power of 3. So negative x power of 3 is negative fx. So this function is odd function. Okay, for odd graph, the graph is symmetry about the origin. For odd graph, when you rotate 180 degree, you will get the same image. Try to rotate this graph 180 degree. Okay, I try to rotate it at the origin. Okay. Okay. When you rotate this one 180 degree, you will get this one. So this is odd graph. For neither function, f negative x is not equal to fx and also not equal to negative fx. Okay, look at this example. Substitute negative x here. Okay, put negative x in bracket. Okay. This one also negative x square. Okay, then try to simplify. Negative x square. Negative x multiply negative x is x square. So you get negative x square. Okay, first compare with fx. You have, okay, check. Fx equal to x minus x square. So when you compare, okay, this one is not equal to fx. Okay, then compare with negative fx. Negative fx equal to negative x minus x square. Okay, equal to negative x plus x square. Then you compare. Okay, they are not the same. So not equal to negative fx. So this function is neither function. Okay, graph for neither function is not symmetry at y-axis nor the origin. Okay, look at this one. You can see that the graph is not symmetry at y-axis. Okay, or the origin. Okay, to determine the type of function, you must know these properties. Okay, first, sine negative x equal to negative sine x. Okay, you can move this negative outside. But cos negative x equal to cos positive x. Okay, sine square x equal to sine x multiplied with sine x. Okay, square here means that you multiply sine 2 times. Okay, sine square negative x equal to sine negative x multiply with sine negative x. Even function multiply with even function equal to even. Okay, you may consider even as positive, odd as negative. So positive multiply positive, you will get positive. Okay, positive multiply with negative, you will get negative. That's why odd function. Okay, negative multiply with positive, negative. Okay, odd is negative. Negative multiply with negative equal to positive. Okay, even function, positive even function. Okay, for neither multiply with even, you will get neither. Neither multiply with odd, you will get neither. Okay, look at example 1. Determine whether the following functions are odd, even, or neither function. Okay, this is the short notes. Okay, when f negative x is equal to fx, it is even. F negative x equal to negative fx, it is odd. But if it is not equal to fx or not equal to negative fx, then it is neither function. So look at example A. We have fx equal to x minus x power of 3. First, substitute x here, all x with negative x. So we have negative x. Okay, put negative x in bracket. Okay, then simplify. Have a negative x. Okay, negative x power of 3. We get negative x power of 3. So minus negative x power of 3. Then simplify. Negative x, negative, you get positive x power of 3. Okay, first compare this f negative x with fx. Okay, they are not the same. So not equal fx. Okay, then compare with negative fx. Okay, but you must check negative fx. Okay, you put negative in this fx. So negative x minus x power of 3, negative x plus x power of 3. So then you compare this one. This is f negative s compare with negative fx. Okay, so they are same. Equal to negative fx. So this function is odd function. Okay. Okay, question B. Okay, substitute negative x. To x square negative x exponent negative x plus 4. Then you must compare with fx. It is fx. So they are not the same, so not equal fx. Then compare with, okay, you must check, okay, negative fx, negative 2x square minus x minus 4. So not equal negative fx. So this function is neither function. Okay, for question C, you can solve by using two methods. Okay, let's try to solve. Okay, let's try to solve by using the first method. Substitute negative x. Cos negative equal to, okay, cos negative x equal to cos positive. So cos negative 5x equal to cos positive 5x. Okay, sine square negative x. Sine square negative x equal to sine negative x multiply with sine negative x. Okay, sine negative, you can factor out the negative. It will become negative sine x multiply with negative sine x. So this negative you can cancel. You will get sine square x. You will get sine square x. Okay, then compare with fx. Okay, you can see that they are the same. So equal to fx. So the function is even function. Okay, let's try to solve this example by using second method, which is by using properties. Okay, we have fx equal to cos 5. Okay, then you separate the function and determine the function, and then determine the type of function. So fx equal to cos 5x and negative x. So this one is even function. So for fx equal to sine multiply with sine. Okay, you will get this one, sine, okay, which is even, because f negative x equal to fx. So you can see that this one is even multiply with even, you will get even function. Okay, look at example 2. Determine whether the following graphs are odd, even, or neither function. For question A, we have this graph. Okay, first check whether the graph is symmetry at y axis. Okay, because first, for even function, the graph is symmetry at y-axis. For odd function, symmetry at the origin. For neither, not symmetry at y-axis or the origin. If you put mirror here, okay, if you put the symmetry line here, okay, this graph, Okay, this graph will reflect here. Okay, cubalah letak cermin dekat tengah ni. You will see that the reflection of this graph will go here. Okay, so this graph is not even function. Okay, so the graph is reflected here. Come here. Come this line. Okay, so this graph is odd function because it is symmetry at the origin. Okay, for question B, try to put symmetry line on y-axis. If you put mirror here, you can see that the reflection is become like this. So this graph is not even function. And then we check for odd function. We try to put here symmetry line here. This one become okay. Okay, we can reflect the image at the origin. Okay, this function also odd. Okay, for question C, we can see that it is reflected here. Yeah. Sama sini sama dengan sini. This one, okay. So for question C, it is even function. Okay, for question D, if you put symmetry line here, you should get this one. You should get like this. Okay, this is not even function. Okay, what about odd function? If you rotate here, it become like this, right? Okay, so this graph is not odd function. Then this function is neither function. Okay, this is example of past question. You can refer the answers in lecture notes. So that's all for today's lesson. Okay, good luck everyone. Bye.